recently there is a pre-trained time series anomaly model, right? That's also the exactly the need. But there's a key difference is that the existing pre-trained anomaly model time series is for single feature. What we are talking about multi-feature. So for example, you want to look at the throughput for your given site. Definitely should look at the number of clients and the total traffic volume we are going through and how many destinations they are going through and how many different applications they are routing the traffic through. So this is going to be multiple features.
All right, everyone. Welcome to another episode of the TWIML AI podcast. I am your host, Sam Charrington. Today, I'm joined by Shirley Wu. Shirley is Senior Director for Marvis at Juniper Networks, where she leads the data science team. Before we get going, be sure to take a moment to hit that subscribe button wherever you're listening to today's show. Shirley, welcome to the podcast.
Hi, Sam. It's a great pleasure to be on your podcast.
I'm looking forward to jumping into our conversation. We're going to be talking about the many ways that you're applying data science and machine learning to the challenge of ensuring high quality network connections for your customers. Before we jump into that topic, I'd love to have you share a little bit about your background.
Yeah. So I started my career as a software engineer, focusing on the data analysis, trying to find the insights from customer data. That is before the big data, Hadoop, and the cloud. At that time, there are a lot of consistent challenges regarding the data volume and the latency issue. Then big data, Hadoop, technologies and the tools and the cloud computing came to the world and quickly took over the whole industry of for the data analysis. So the capability to process large amount of data really accelerated and the development and deployment of AI related applications. So the primary application we're doing is the business insights are definitely not enough anymore. We quickly moved to the capability to predict and forecast for customers' needs. So at that moment, I take the leap of my career to get into the startup. I joined the early stage startup in cybersecurity, trying to use AI data to solve the cybersecurity related problem. So we are, one of the first industry, trying to profile user behavior to identify security threat. So that company eventually was acquired by Aruba Networks. Then that's our first, the early stage startup. Then I came to Mist. Mist, was a Wi-Fi company, but it's different from the Wi-Fi networking company. It is also a cloud company. So I joined the Mist to start to develop AI related technologies. So the company spent, quite a few times, quite a rounds of development to cloudify all the networking Wi-Fi access points and build the cloud infrastructures to be able to capture the data. Then we have data in the cloud. That's pretty much the prime time to develop AI ML solutions. So I was kind of architected with a group of very talented data scientists and engineers to implement the Marvis self-driving network solutions. And currently, we continue expanding Marvis, to the end-to-end networking, starting with Mist with Wi-Fi only deployments. Now we are developing to the Wi-Fi, wired, and the WAN, trying to utilize the data and the AI to help the customer to have a better networking experience, have a better internet experiences.
When I think about networking systems, and I spent my early career at AT&T working on data networks and um, configuring routers and all that stuff. So I have some degree of familiarity with all that. Uh, I think a lot about the type of data that those systems tend to generate, and it's mostly log files and like time series data. Um, and to a large degree, while that space is evolving, rapidly. Some of the most exciting changes in AI haven't necessarily, included time series. It's been about language and images. So I'd love to have you share a little bit about how you think about the evolution of ML and AI from a time series perspective, and also more broadly, networking as a application area for ML and AI.
Yeah. So your question is right spot on. Why networking is really the domain suitable for AI and ML? First is networking is a matured domain, right? Not much of the significant, revolutionized the changes for the networking domain perspective. So because of heuristic and the domain the level its maturity, so that's capable for AI and ML, right? So this is the first layer. Second is the Mist. We started to develop the network gears purely like an IoT device. So purely we have visibility about the stats and events from the cloud. So as the device, the starting to power it on, and they auto connect to the cloud, starting to report its stats and the events. So in the cloud, we have a large amount of data, purely can clearly identify current state of that device. So that's give us a capability to do the AI and ML. Now, third piece is about the revolutionize from AI and ML perspective. Like you said, currently a lot of a revolution, development in the AI ML is focused on the image and the large language model. Time series, from people's perspective, it's mature already. It's a done problem, right? But for networking, it's another domain. If you talk about time series for to forecast particular stock market, or for the advertising for financial marketing, that's pretty much is mature. Um, but for networking, it's a special domain. A lot of the, you go to market, you can find a lot of the people that have a good experience with data science and ML in advertising, financial services, not necessarily networking domain. Networking domain is a very special domain. So it's really hard to find that type of talents, which they know the expert about networking and also about AI and ML.
When we think about time series as a problem class, a lot of the things that you're trying to do are very similar in terms of prediction. Are the problems fundamentally different in networking?
Problem is fundamentally different. For example, for Wi-Fi, how the Wi-Fi mobile client to join a network, there are multiple phases it goes through. So this we have to sit together with our domain experts to understand multiple phases, and each one of handshake between your Wi-Fi client with your access point, the acceptable latency, which layer they're going to retry. So this is the type of use case perspective is purely need to well defined while we work in the specific use case with our domain experts. So this is the one point. The second is, like you said, if we can real interpret that the domain specific problem with the data, then the problem is pretty much done. A lot of times, the data scientist team, we're working together with the domain expert. First, to identify the true problems they discover at the customer side. Then we study the data to make sure our data be able to interpret, have all the descriptions about the particular problem. So in the data science perspective, they call the feature engineering, right? So when we do the feature engineering, a lot of times we kind of really identified that, hey, maybe we even don't have the right data. So our device did not send that particular stats or events to the cloud. Then we have to go back to work on the AP firmware side to able to capture those stats, send it to the cloud. Then we start to redo the feature engineering. Then the third piece was that when we identify this type of issues, for example, for retail customer, because their Wi-Fi configuration is different compared to college campuses, which is also could be different compared to the business offices. So we take that particular domains, the deployment is a problem. We also trying to, the generalized for college campus and for the campus deployments, for enterprise campus deployments. So in this case, that we have a generic solution, not just for a specific one customer, which is not going to work for customer B, right? So it's the three layers of the problems that we are talking about.
You just kind of lay out the problem. You've got these Wi-Fi access points that are spread throughout whatever facility, and you've got these clients that are trying to connect, and you ultimately want to have the clients have the best experience possible. One aspect of the problem that's kind of offline is there also an online component where you're deploying models to either clients or access points that somehow aid them in making the right connections to one another that facilitates a better experience.
Yeah, there's multiple fronts, multiple layers actually. AI ML, it's not just a one solution, actually it's every front. So for example, let's say I can give you multiple examples. So first to start is what is the feature you're talking about, the auto radio resource management. So when a mobile client trying to join an AP, you need to make sure the client can hear the AP on the particular channel. You can hear the Wi-Fi signal strength should be optimal, right? So you deploy the access point everywhere in the parking lot, inside on the roof, on the the ceiling of your room, and in the the dorms. So every environment that also maybe the other radio signals, if you're close into the airport, if another, if the shopping mall in the retail store, there's a next door, there's another access point, maybe from the different vendors, right? So all these very dynamic environments, we need to make sure our access point have the right signal and on the right channel so that the client for this particular store, they are able to hear you clearly. So in this case, we have the models deployed inside the cloud and they are adopted for each environment. And based on, we call the reinforcement learning. So we select a particular channel for every site, and based on the feedback information from the stats and the events, we continue to fine tune the selected, the channels and the mod and the power strengths. So this kind of, more like a have a global model, but being fine tuned for each site, and also based on the feedback loop, based on the stats and the events data, we continue to fine tune it for each environment. So it's kind of one of the use case, right? Of course, when we start this journey, you first need to do the offline analysis to define that type of model. Then we deploy it to the cloud. Then utilize each site data to fine tune the model. So this is kind of one of the use case. So this use case actually compared to traditional, networking company for Wi-Fi, they typically use a controller. Controller is a piece of equipment they deploy it at the customer's site. Then you need the network administrator to manually configure that controller, right? So in this case, our solution is purely utilize cloud, utilize the data for each access point. We totally eliminate that extra components. So this is kind of enable our customer, for example, one of the largest retail customers, they have a very small team. They can support the Wi-Fi deployments globally, all their retail stores. So our solution enables them to do that. Another, of course, that we call it the AI for operation. So we use AI ML to support the customer's operation. What does it mean is that you first get your networking configured, deployed. Everything's great. Then our SC work away, so there's our networking running. But typically network hardware companies they do is if there's a problem, your IT administrator just pick up the phone, working with the support to get the issue resolved, right? For us, actually, after the first initial site going live, the data and the events continue streaming to the cloud. We monitor your network operations. If there's something's not right, we are supposed to be able to notify you ahead of time. So, for example, we'll monitor the site number of client, the counts, This is just, if you're the college campus, you can see daily trending, right? Up and down. You go into the college room and go to the classroom, then they come home and to the back to the dorm. The the line is up and down, up and down. We can build that line to build the anomaly detection model for every site. We can notify you some abnormal sudden drop of a client count that definitely indicate something is not right for your given site, right? So this is kind of another back to your question. This is a time series detection anomaly model. But here's a challenge for us is that how you want to make sure your time series anomaly detection model is accurate. Think about our scale we're running. We have close to 100,000 different sites deployed across the world. And if we have every site, we have a anomaly model, which is a neural network based model. So which means we're going to have 1,000 neural network based model. This is too expensive, right? It's a one model is fine, but this is that scale is too expensive, too costly to maintain. So its cost also is another factor. Efficacy is definitely the number one issue, but the cost is also second the most important factor to make our to further decision.
Can you elaborate on that? Where does what's the relationship between a single model and the cost?
So, for example, for let's give an example. Say, hey, for the retail store, you have a daily pattern. The customer going to your store to visit. Daily pattern probably the weekend should be higher volume versus a weekday, right? And the weekday during the normal business hour, probably is not many people go to your store. Probably going to be even time. But versus for
The
the
university is going to be almost opposite, right?
yes, yes,
Okay.
and the trending is different. So for in that case, you can have a neural network based model to learn your daily pattern for the retail store versus for the university. If the pattern is totally opposite or totally not in line with each other. So in this case, the best efficacy training was that for each, the line, each trending line, we created their own neural network model, right, to the forecasting. Same thing, like say, hey, for stock market, you want to predict a particular stocks trending, you train a neural network. But if you want to follow in multiple stocks, they're trending, you probably need to train multiple neural networks, right?
So we talked a little bit about time series as being somewhat of a solved problem, quote unquote, but that isn't to say that people aren't trying to create transformer based models for time series. I'm curious if to what degree you've explored or found any interesting solutions there. Um, yeah, it sounds like that could be interesting for your problem where you've got some base level model that you can fine tune as opposed to creating many distinct models.
Yes. So that's exactly what the here recently there is a pre-trained time series anomaly model, right? That's also the exactly the need. But there's a key difference is that the existing pre-trained anomaly model time series is for single feature. What we are talking about multi-feature. So this is actually that's another piece. A lot of time series recent development advancement is only for single feature.
Got it. So you've got a log of stock prices and you're trying to predict future stock prices, or you've got, in your case, a log of like RSSI, would that be
Yeah,
one of
exactly.
your
Yes,
I
yes.
forget what that
RSSI,
stands for, but it's a measure of
single stress.
noise,
Yeah.
signal strength, yeah.
Mm-hmm.
And you're trying to predict the future RSSI so you can figure out which channel to join or something like that. But I'm guessing that you've got this log with a lot of different features and you're trying to make multiple predictions based on
Yeah.
as opposed to a single one.
Mm-hmm. Yeah, yeah. So this is so for example, you want to look at the throughput for your given site. Definitely should look at the number of clients and the total traffic volume we're going through, and how many destinations they are going through, and how many different applications they are routing the traffic through. So this is going to be multiple features in the real world problem, right? So this is also the reason why the pre-trained time serial anomaly model is very promising, but unfortunately it cannot work for us. It's a single model.
I'm relating it a little bit to my personal experience. I've got a small, network here with multiple access points, and I remember when I first installed this latest version, I would go into the management software and look at like what client was connecting where, and to try to address performance issues. And I noticed that the decisions didn't really make sense to me. Like I would be, I would be in a one room and the laptop would connect to, a distant access point. Um, and I'm just thinking about like, if it was that complex for me, like, and I was never able to resolve it. I just had to wait for the software to get updated, and it kind of resolved itself. But if it was uh, complex for me, like at the scale of a campus, the complexity multiplies, obviously. And so it seems like an obvious place to add some intelligence, I guess, is the point that I was getting at.
So it's another thing that is for example, we wanted to transform a network into networking. Previously, just like I said, you need the really domain expert network administrators. They do a lot of troubleshooting, doing a lot of cool stuff, right, to find the data, to correlate, to find the root cause, because that domain is mature enough so that we can write the software to embed those domain experts into the software to help some of the no-hanging fruits. So that so the network administrators, they can focus on more complex problems like security related, like large deployments configuration, right? So we are also transforming a lot of network administrators from the just the manually cool shell guy and understand the network gears to be API engineers, because we export all our data to make it available through APIs to the customer. So they can utilize the data to develop use cases for support their own specific environments. So it's a key difference here as well to kind of empower our customers.
You mentioned in your earlier explanation the use of reinforcement learning. That is sometimes associated with using simulation. Is simulation a technique that you use often there?
Actually, we did not really utilize simulation. We just test our own. So our office is a test lab. So we are all part of our test. Our latest algorithm to reinforcement learning. Reinforcement is a part you develop that the awarding function, right? What is a positive or negative award? So this is the one that we continue in the cloud. We always do this type of A/B testing. So first, put a smaller, friendly, different type of deployments into the this latest algorithm. So after we have a confidence, then we deploy it to the Miss. We call the Miss Universe, which means globally to all the cloud environment.
And so Mist is kind of an umbrella term for all of the Juniper AI related capabilities.
So actually, Mist was a startup. Actually this week will be hit our 10 years anniversary. We started as a Wi-Fi, only focus on the Wi-Fi, and but the next is Wi-Fi is different. It's a Wi-Fi access point is totally cloud driven access point. So about 5 years ago, Juniper acquired the Mist. So this acquisition is a benefit for both sides. For Mist, we used to use Wi-Fi. After we part of the Juniper family, we got the switching wired and also get the WAN gateways. For Juniper perspective, Juniper does not have a Wi-Fi, never been a Wi-Fi company. So now Juniper got a Wi-Fi, and also Juniper is not a cloud company. So now it's a cloud, and of course, Juniper continue to utilize Mist cloud technology and the AI ML to try to expand into not just for enterprise, which is wired in the WAN, and also to data center. So this is kind of the currently is 5 years after acquisition. Then we're going to be soon embark another journey to be part of the HPE family. But the acquisition is the same goal. Wanted to continue utilize Mist as AI ML solution for networking to be exposed to the much larger networking deployments.
I came across one of the initiatives under that umbrella called Marvis. Can you talk a little bit about Marvis and what that is aiming to accomplish?
So now one hand, we have a lot of backend jobs running, right? Crunch the numbers to process user data to generate alerts, events. Now, second is how we want to make sure, how we want to change the user interact with our application with their data. So we utilize Marvis. Marvis is, think about it, is actually Marvis where it came from is from Java's.
Miss Jarvis?
Yes. And
Okay.
it's a bot. They can understand a lot of languages. And you replace the first letter is a mist, right? So that's why it's called a Marvis. So first, Marvis is how user can interact with their the networking issues. So we first started with troubleshooting. So you can always go to the UI, just troubleshooting for your particular client, particular device, or particular issues. That's early day use a command line to do the troubleshooting. Now we evolved into a chatbot. So you can just go to the Mist UI. You can just go to the chatbot asking questions about why I cannot connect the Wi-Fi, why my AP is continuously rebooting, why my AP was disconnected from cloud, right? Why my AP? How can I do the AP firmware upgrade? So we add the chatbot support, but the chatbot support actually was developed even before this whole large language model took the world. So now we are sort of another enhancements to our current chatbot to integrate with large language model. And actually recently you had a great conversation with the LanGraph CEO, right? LanGraph. So actually, we're integrate that LanGraph into our chatbot. So the and also you could go to the Marvis to asking questions about a specific networking domain, or Marvis or Juniper related product questions. Instead of we give you the documentation to read through it, we can summarize the specific answers and provide a real precise response to you. So this is kind of the just we first we develop our own RAG solution to be able to do this type of summarization, focus on our public documented release notes and documentation pages, so that we can provide a precise Juniper related product features to our customers. So they don't have to read through all the technical documentations and the wiki page for yourself. This is one part. Yeah. Second part is that we want to utilize large language model to be better understand what customers are asking, and also develop our own text to SQL, text to yes type of solutions, because all our data inside the SQL database or Elastic or the non-SQL database. Before, in order to expose those type of data, we have to create a lot of different APIs. While we just use a large language model help us to expose all the data together with the customer, right?
Got it. So based on whatever the customer's intent is, you turn that into a query against the database.
Yes, that's another use case. Because as of now, we're committed and not sending the customer data to large language model, but we actually utilize large language model to create a lot of embeddings for our internal metadata. So for example, how we store the data in our database, we create this, we call it data catalog, or we actually create an embedding and also provide a rack solution so that we can match the customer what they're asking with our data much better.
So a couple of follow-up questions there. First, you mentioned working with LangChain and LangGraph. I'd love to hear a little bit of your experience and motivation there. There seems to be bifurcation. Some folks appreciate the kind of standardization, if you want to call it that the LangChain offers. Other folks like to go straight to the metal and kind of do it themselves, and you know, skip an intermediate framework that might hide some of the either complexity or features that they need to know. Like, what drove your decision to use that?
So currently, our integration with LanGraph, we did not go full in. So for example, a lot of large language model related features, we build our own smaller model. So it's kind of multi-model type of a scenario in order to, because like I said, first, the networking is a very special domain. And a lot of networking jargons that our fine-tuned model probably going to do it better. But on the other hand, some of other questions that the large language model can help us to close the gaps. So we actually running this as a large language model. Our own fine-tuned model is running in parallel. So because of this, we um, does not go full in into the name graph and with large to handle all the dialogue and also the assistant, right? So we kind of build those tools a little by little. Like I said, we feel don't have a confident we want to all in with a name graph. Like it's exactly what you said. You have some customer wanted, some of our audiences they want to go all in with name graph. Some of them just we are probably the second layer. We wanted to have our own control and doing our evaluation. Then we kind of integrate with the name graph piece by piece.
Got it. Got it. Got it. Yeah, I hear that quite a bit. And then the other question is with regard to RAG. You've mentioned that a couple of times. I have talked to many organizations that start down this journey with RAG and primarily expose it via a chatbot, but find that um, kind of going beyond that chatbot and integrating more tightly into existing, workflows and user interfaces without requiring that chat dialogue experience is a source of even more value from the RAG as a technology. I'm wondering if that's something that you've seen, and if so, what are examples of those workflows that you're looking to enable?
Um, so for example, for us, like when customer try to open up a support ticket, before they open the support tickets, when we look at their questions they're asking, the problems they're dealing with. So if it's questions about our product and the features, then we just use RAG to generate response for them. Just another layer to say, hey, maybe this is what you want. You don't have to create a support tickets. So this is kind of a lot of integration with the customer support, good user experience as well, right? So we kind of expanding that not just for the chatbot. We kind of integrate with customer support. Another example, actually, this is a good question. Is a large language model. How are you going to prevent hallucination? For networking, beyond the troubleshooting and customer support, the good user experience, we are still hesitating or has not really productized this feature. Like say, hey, can we just utilize rack solution to generate a config for my network? Well, even though LM, let's say we can get to the efficacy to 90% or 99%, but that 1% of a failure, 1% of failure is not acceptable, right? So because of this, we have some experiments, and we're probably going to be just more like the recommendation perspective. Still need a human to do the final validation before we can release it. So this is kind of the challenge. Depends how much the efficacy is acceptable for us. 0.1% of a failure rate is not acceptable.
Interesting. So you talked about a couple of examples so far. Um, you talked about kind of channel selection. You talked a little bit about like proactive monitoring and fault detection. Are there other examples that you can share with us about, where you've integrated, your integration of ML and AI have uh, produced interesting results for your users?
Yeah, so it's a anomaly detection is it's a general, right? So we monitor customer, but beyond that, for example, it's okay after customer deployed the site in the beginning is perfect. As number of users is going on and the usage pattern is different, then we kind of realize that your current deployment may not be optimal. So, for example, there's suddenly a coverage hole showed up on the AP access point, so in this case, that we are, yeah. So how are you going to detect that? So we continue to monitor your coverage usage and the capacity, and also the RS, the transmission failure rate. Then we'll report to you around this corner of the office. There is a coverage hole. You probably need to adjust your AP access point and also increase AP deployment on this side of the office, right? So it's the another very good use case is we are monitor your user experience. That's a key thing, user experience. And the second point is that after you get the network configured, then you continue making the change to your network. What if accidentally all this configuration, you're missing some configuration between a switch? How you do it now? So that's the thing. We're always comparing the switch, every interface port configuration for VLAN. Then if there's any missing, we'll report to you.
What you're trying to identify there is like network engineers in a console and like fat fingers a configuration and deletes a VLAN or something like that. And all of a
Mm-hmm.
sudden, like a segment of the campus disappears or
Yes, yes.
connectivity to an application disappears. Okay,
Mm-hmm.
interesting.
Yeah. Then another piece is, hey, you get everything's running, but suddenly the cable somehow deteriorating the performance. How do you know? Then certain error counter that will give us indication. So we kind of based on the broken cable build, for copper cable versus fiber cable, build different ML models, and based on the switch, the device reported counters errors, then we are able to identify the cable was had a, had broken, so need to do a replacement. Otherwise, the user experience traffic will be getting impacted.
For that particular one, why is a ML model needed? It seems like either you would have the cables really broken, like you have no electrical connectivity and the link is just down, or maybe it's kind of it's not all the way broken and you just have a really high packet loss rate or something like that. And there's some threshold that you would set to know like what's the complexity that requires ML.
So packet drop could be a lot of reason. One of the reason could be the cable broken, right? The packet drop is specific for the SD-WAN could be, the ISP related the service problem, ISP server problem. So not necessarily cable. Cable it's really the so yeah, that's the thing for networking. If you look at the data, there's a lot of issues you can find. Like the packet drop always happens. If you build a normally model, you probably could find, hey, suddenly there's one day the packet drop is, it's suddenly increased. But what is the cause? Right? There's a lot of, if you just want to looking for problems, a lot of problems, but you truly identify the root cause, the reason contribute to this packet drop to be a cable issue. That's a hard part. Right. So that's the reason why for a cable issue, we specifically look at um, the device reported the error counters, such as error counters. So that's also the this type of problem is very vendor driven. So for our device, Juniper device, we have a certain confidence about the stats, the reporting, the way they're reporting the data, and our model is pretty much tailored to our device. So for other other vendors' device, how they report those type of issues, that may not going to be work. That's also the challenge for this networking domain as well.
Meaning you've got a specific way that you're collecting that error data?
Yeah, so how the device report that error, that is how frequent they report that error. And so those going to impact our detection logic and the model we're building. That pretty much the feature engineering that effort, because this is more like a build up a supervised learning based on the label data. We build a supervised learning, right?
But also time series or not time series for
This is
this?
not necessarily time series.
Is it that a single instance of this error, or the error is like classed, a single class of
It's a
error
big
is?
class of error, and you look at the same class of errors, and also look at the duration of the error.
So you kind of featureize those two things, and based on that, it will flag a cable issue.
Yes, yes. So this is also based on, like I said, based on label data. So we have a few of the cable issue for copper and fiber, different type of cable.
Interesting. Interesting.
Yeah. So all this stuff is yeah, it's a kind of AI ML related. It's very specific to networking domain problems to help the AI for operations. So after your network deployed, and we are doing the monitoring for you instead of from customers that they maybe someday someone complaining how why my performance is going bad. Then the network administrator then doing some digging, they realize, oh, must be cable issue. Oh, there must be one of the VLAN we forgot, right? So this kind of fundamentally enable our customers that be able to have a large deployments. They can focus on much larger, bigger scale problems.
Got it. Got it. Do you track, in the case of a larger scale customer that's like using all of the features that are available, like how many ML models are coming into play and helping them manage their network?
Mhm.
Like, is it
So
tens or hundreds, or like where are you with that?
you mean the numbers of the models we deploy in the production?
I guess the thought is that you've got some ML solutions where, like, it's, it does one thing, it's a big thing, and it's kind of central to the solution. In this case, what's kind of interesting is that, there are a lot of little things happening behind the scenes that are kind of silently made better by machine learning. And I'm just wondering, like, how many of those, how many models are required to do that. I'm assuming that it's a lot of different smaller models as opposed to one giant model. We kind of talked about that earlier. So
Yes,
that's why I
exactly.
was
Mhm.
asking.
Exactly. We have a lot of smaller models to do this little magic, not just one large model. Actually, we have, large model is a large language model. That's that's actually we don't have that. We utilize third party hosted large language model. Internally, we have quite a lot of neural network based model, like I told you, shared with you about the time series anomaly detection. But that one actually is, we are at the stage we need to change the way we did the time series anomaly detection model. Maybe the next episode I'll share more about what we're doing. Yeah. Then on top of that, we have a lot of smaller model, like cable detection and misconfigured port. Even for radio resource management, we have very specialized small model. The reason is, like I shared with you, is actually three factors to decide for this. One is efficacy. Second is a latency. Smaller model have a small latency. Third is debuggability, and also the cost as well. Yeah. So we got the problem question: why you make this decision? How we're going to debug? So of course, one is a supporting evidence. We have all the data. We can show you the time series supporting evidence. But a lot of times, even look at supporting evidence, we kind of puzzled why the model behaved the way it was. So that's also the debug capability for us to fine tune our smaller model is much faster, quicker to get the new solution deployed in the production.
I'm imagining that for many of these features, like, there's a traditional way of doing things, like maybe, the traditional way to do faulty cable was some threshold on an error rate or something like that. And then, um, there's machine learning based way to do it. And uh, I guess I want to get a sense from you, like, how you think about balancing, the complexity versus the data requirements, and like when to make the transition and that kind of thing. Like, is it just a product management thing? Like, if there's some gap that you're not able to get in terms of capability, and this is a way to get there, then, you kind of go in a direction, or are there other ways that you think about making that transition?
Yeah, so actually you brought up a good point. It's actually a lot of our product management, we are just working with them about the particular use case. How are we going to solve this problem? First is data in the cloud? Do we have the right data? Then after we have a data in the cloud, so data science team, actually we working not just with the product management. A lot of times we're working with the customer support team, so they are then to study the use case. So like you said, is maybe heuristic is good enough to solve this problem. Why we need to spend effort to train a model to utilize AI MLs? So, but anyway, the key point is first is the data. Second is do we have the heuristic? Do we have a solution? Doesn't matter is a human, magically sifts through all the data to find the problem, or write a piece of software to solve the problem. Fundamentally, we need the data to solve the problem, to make our customers' internet experiences better. So that's a key. So for the data science teams, actually, a lot of times we are not really doing training a fancy model every day, but actually a lot of time we are doing is a feature engineering. Feature engineering, you probably heard a lot from data science team ML. A lot of time they are doing is a feature engineering, trying to study the data. Does the data really contain the information we can solve the problem? Do we really need a neural network, or just regression or heuristic baseline, right? That can solve the problem.
So we talked a little bit about um, some of the ways that you are incorporating LLMs and Gen AI into your solutions. Are there any future directions that you can talk about? Where do you see all of this heading for Juniper?
Yeah, so it's two things I can share with you with Juniper. One is not related to Gen AI, but it's actually currently, Juniper, we utilize the data and the events. Actually, we are detect the problems which has already happened, which already impact the customer experience. So how can we take it to the next level? We can proactively identify the problem before user experiences this issue. So this is a kind of, we utilize all the devices we deployed in the globally. We are able to inject, from cloud to push down a little piece of software to proactively test the customer's network. So that way we can proactively identify the issues. For example, every night you did a configuration change for the network, we can start it to automate the tests on on your networking. So before people show up 8 o'clock in the morning in the office, we pretty much report to you your office is ready for people to work or not. If the issues, you should already send the alerts to the network administrators to address this issue. So this is called the Marvis the digital twin, the minis. So that's the one we already running in production, but we are trying to progressively to increase the capability of the minis, the test scope.
Where are these minis running? Are they
Running
running
inside
on, like,
our devices. So you
meaning
have
from one access point to another that you're testing across, as opposed to like from a client, like a user laptop?
So it's inside access points. We're gonna have minis inside the switches, minis inside the SD-WANs. All the Juniper switch devices will capable to support the minis. Yeah. So this is kind of really proactive, identify the issues before any user experience this networking problems. Mm, yeah. So this is the next big direction the company is moving to. Another for Gen AI is that right now our application is a little counterintuitive. For example, our application um, first is tailored for network administrators. That typically, if your network is running perfectly, you don't need to log into our UI. You don't need to look at the order graph charts, right? So um, then want to move to the next level, but then think about it, if you are college students, you cannot join to your college classroom, you cannot join the Wi-Fi. What are you going to do? You call your college IT administrator, complain about your problem. So then we wanted to do, hey, let each individual Wi-Fi user to be able to do the self-service, self-identify the problem. So we're going to build another feature so that as each individual user, you can troubleshoot. Then we'll tell you specifically what is wrong. Maybe your guest Wi-Fi password was changed. You need to contact the IT administrator to find the correct password, or your cert expired. So those type of problems that can give you much more information versus you call your network administrator. So I'll tell you your device have a security patch it didn't apply. That's the reason why you cannot to your Wi-Fi, cannot connect onto your network, right? So this type of problem that the need each individual Wi-Fi user to solve their problem instead of flooding the IT administrators. So that's another one we are trying to utilize Marvis to not just serve the IT administrator, also serve the individual end user.
And I'm imagining that the logical next step there is, some of these problems are going to be, the result of network issues as opposed to user configuration issues. And then you're just kind of collecting user experience data that you can use to either inform the network administrators, and like you already, go figure out what the root cause is, or, at some point just fix it if it's fixable.
Exactly. That's when we wanted to collect the user input data. Do they really have a capacity issue? Do they have a really slow experience? So for Marvis and we right now we are doing very good job to identify why you cannot connect the network. We solve that problem is pretty good. But now we are moved to the second is the slowness. Slowness is very it's a hard problem. First is the different applications have a different tolerance for the networking capacity. Second is slowness also is depends on what type of applications you're using. Third is a very subjective for each individual user's personal perceptions, right? So the user feedback can give us a lot of input data.
Very cool. Well, Shirley, thanks so much for jumping on and sharing a bit about some of the ways that you're using data science, ML, and AI to help us get better networking experiences.
Yeah, it's a great pleasure to chat with you, Sam. So have a good day.
Thanks so much.